Welcome. I should say good morning, good afternoon, good evening. We are all used to hearing that now in this global webinar period that we're all in. So thank you very much for joining. I'm Kristen Williamson, CEO of Petrus, just delighted to be hosting you for the last in our series of the Coursera Executive Forum for this year, and very grateful to Coursera for working with us to put together the concept and the subjects and the speakers behind what has been an absolutely fascinating series of conversations that has taken place this year, all around the topics linked to digital education, which I know are what you're joining us to listen to and to talk about as well. We'll be exchanging together by the end of the session. Looking forward to that. So a few practical points, and then we'll get straight into our subject today. We've got a great audience, literally from all over the world, although with a real focus on Europe and the Middle East and Africa. We have deans of engineering schools, we have directors of education, we have representatives from industry, a lot of people passionate about education and what we can achieve with digital education, which is perfect for the subject that we've got today. You'll be happy to know that the discussion is going to be recorded and you'll be able to have access to that recording. You'll get an email following the webinar with that information in it. You've obviously got the chat, and I can see many of you are using it already to introduce yourselves. Fantastic. Please keep on doing that, and please do also ask your questions in the chat or in the Q&A, and we'll make sure that there is ample time to cover those later on in the conversation. And one new thing today, which I just wanted to highlight right at the beginning, I know that often people, one of the things that we all miss in this online world is having the opportunity to interact with those that we meet online. So we've got just a very short networking session using the application Wonder at the end of the webinar. It's optional, of course, so please stay to the end of the webinar. If you want to stay for an additional 20 minutes, we'll post the link. You don't need to have any special tech or tools to join, and that gives you the opportunity to meet one-on-one or in small groups with people who've been here today. So please do join us for that if you possibly can. So thank you. And with no more practicalities to cover, I will jump straight into our topic, and it's really a hot topic of the moment. I mean, I see the number of webinars and invitations that I have. Just this morning joined a session with the Financial Times on this topic of reskilling, upskilling, the digital skills and the emerging technology skills that people are going to need for the future of work. And with the technology advances that are happening today, and of course the context as well of the COVID pandemic, but in particular, the emerging technologies really fueling the need for digital workers. There are simply not enough trained workers in the world to cover the data, the AI, the automation jobs that our economy needs, and actually that offers the opportunity to people to have a fulfilling career. Right now in the USA, 1 million digital roles unfilled, 46% of US employers saying that they cannot find the talent that they need for digital roles, and that figure increases to 76% if we look across the rest of the world. It's really significant. And with that in mind, also thinking about 40% of people, this is data that I heard this morning from the European Commissioner on digital skills, left behind, not having the skills that they need to be able to connect and work in a productive role. So on one hand, we have an economic issue. On the other hand, we have a really human and personal issue that people could be in satisfying, fulfilling roles that possibly aren't, and we need to address that. So what can we do? Coursera have published a fascinating report on curriculum mapping for student employability. And I'll ask my colleague Dominic to share the link to that in the chat. And that's really a premise for our discussion today. How can blended learning enable us to better address rapidly adapting engineering courses for employability, and to make sure that engineering students in particular really have the skills that they need and that will allow them to integrate into the jobs and the roles that companies are looking for. And we all know of the complexity of developing an engineering program. So how can we do that more quickly for some of these emerging technologies to make sure that people have got the skills that they need. I could not have a more experienced and a better panel to discuss this with me. And I'm just going to introduce by in alphabetical order, in fact, and then we'll jump into our questions. I'm thrilled to be joined by Jan Bunel, head of the SRCD department, Network Systems, Cybersecurity, Digital and Law at the IMT Atlantique. IMT, for those who don't know, Institut Mines Technology Atlantique, and also working at the Rennes campus of the same institution. He's a full professor and also head of the SRCD department, so Network Systems, as I said, Cybersecurity and Digital Law. His research topics mainly related to data stream analysis over big data and models for large-scale distributed systems and networks, right in the thick of the topics that we're going to be discussing today, and also as a full professor, you know, in front of students and engaging in many different ways with the classroom. So can't wait to hear from Jan. Jan will be joined by Cécile Ardebol, who's teaching advisor at the Center for Digital Education at EPFL Switzerland, École Polytechnique Fédérale de Lausanne. I'm sure that you know it. Cécile, originally an engineer, holds a PhD in computer science and is really supporting EPFL teachers on innovation projects in teaching and learning, particularly interested in the flipped classroom. And we will have lots of questions for you on that, Cécile. Thank you for joining. Then Stefano Olivieri. I'm delighted to have Stefano with us. He's been involved in a number of our events in the past, Customer Success Manager at MathWorks. Now, Stefano received a master's degree in electrical engineering at the University of Bologna, continued his studies in engineering, but has been with MathWorks since 2005. And he spent 8 years as a senior application engineer, now working as Customer Success Manager. This brings a really unique perspective. He's working with the academia group, helping institutions, research institutions as well, to adopt MathWorks tools for effective teaching and research. And Stefano's connection with industry and the evolving needs of industry bring a really valuable perspective to the panel today. So thank you, Stefano, for joining us. And finally, to Carlos Salgado. Carlos is Director of Strategic Partnerships and Business Development for Coursera, particularly leading out the strategic relationships in France and Switzerland and Spain. And Carlos, working directly with leading engineering schools in Europe, like EPFL and IMT Atlantique that we have with us today, is at the forefront of understanding what are the intricacies that affect engineering schools in today's environment, and how might they integrate different forms of blended learning to adapt. He is, I know from speaking with him already several times while we've been preparing, passionate about this collective adventure that will help us to shape the education of tomorrow and even the education of today. So welcome everybody. I am just thrilled to have you with us and very much looking forward to addressing the questions that cover this exciting topic. And maybe we'll just jump straight in to a question with Carlos to make us start. We've talked about these emerging technologies and you know, everything's that changing so fast. And I wonder, Carlos, what kind of skills do you see engineering students need to be learning to be career ready? And maybe how is Coursera adapting or providing something that helps to respond to that challenge?
Yeah, great. Thank you very much for the great introduction, Kristen. Pleasure to be here. You know, at Coursera, I think we're lucky to have 92 million learners worldwide, well distributed around the world, which gives us a lot of data. And as you mentioned, the reports that we produced is based on a lot of this data. Now, one thing that drives these skills, like what are the skills, you know, you mentioned that we need in engineering today. One thing that drives the skills, as we know, is obviously employability. What are employers looking for? And the way I see it, from when you look at this data and what Coursera is doing, there's two ways to see it. Is, hey, what is happening today, and what are we doing today, and what is happening tomorrow, and then what are the skills that will be needed tomorrow, which I think will be quite different to what we have today. In today's world, when you look at the data, you know, it's interesting to see that globally skills are very, very dispersed and different in different geographical locations. But when you aggregate all of this, there's two main phenomena that happen. One is that you have a lot of emerging new skills that attract the masses. And I think these are skills that are short to fill and small gaps that we're seeing in the markets and that are important for our engineers to have, such as, well, some of them include, or the three main ones include machine learning, as you might have, as you probably know. So we have, introduction to machine learning or machine learning regression, machine learning classifications, which are key topics that are being learned and uptaken very fast by engineers worldwide. Then you have robotics, more for the mechanical side of engineering, which is also taking a huge uptake. So, robot dynamics, kinematics, or generally just motion planning and robot motion, which is also taking a lot of importance. And last but not least, everything related to big data and cloud. I kind of bucket this together because it's big data, but what do you do with that data? You put it on the cloud. So big data, cloud, and then programming around this big data is something that's also more and more important in today's world. But that's one phenomenon. So sort of emerging skills, fast emerging skills, short gaps. But what we're seeing also is there's some gaps that are growing and that are a bit longer to fill, and that I think are also going to be a bit more of a problem in the short to medium term. And these are skills that we've identified will take approximately between 25 to 45 days for learners to fill. And 45 days is a lot of time. If you put that in terms of time, it's almost like a full semester. And these skills, there's three main skills here that we've identified as being key skills, a gap that need to be focused on is statistical programming, data management, and operating systems. And these are three of the key skills that will take a bit more time to fill, but that are also being very high demand from employers. So relating back to the idea of employability. And that's for today. This is the data we have. This is what we're able to see. But what's interesting is also to see what's happening tomorrow and what the world will be like in 5, 10, 20 years. And there's higher growing demand in terms of expectations from employers. Our engineer learners today have to have interdisciplinary skills, which include, everything that you teach, but then new technologies, new tools, etc., because technologies are disrupting the way we teach and everything that's happening. But also, I think something that we're underestimating is the idea of remote work, which will eventually also bring more pressure on students, because all of a sudden they'll be competing with universities worldwide, because employers can all of a sudden just, recruit people from a wider range or a wider geography. And so I think this is all leading to, no one has the answer of what the skills will be of tomorrow. We know what they are today, and I just mentioned a few of them. The reports will give a bit more to that. But what I'm more focused on and curious about and passionate about understanding is also, what will happen tomorrow. And obviously lifelong learning and digital as an ally to teaching will be a key factor to take into account. And I hope I've answered your question, very long-winded answer, but I hope that makes sense. And I'd be happy to go into detail.
Fantastic, Carlos. And Noah, in fact, what you've done is highlighted a few really interesting topics for us to plunge into as we progress. We will definitely come back to this question of employers and credentials, and our employers ready to look for different kinds of credentials, and lifelong learning, which somebody described in the session I was in this morning as a buzzword, but actually lifelong learning has been a concept in Europe, at least, and in many other places around the world for a long time. But I think it's only now that we're really understanding what it is and why we really need to address it seriously. So we will definitely come back to that. Thank you. Maybe just having heard from you on how Coursera is going about analyzing the data and looking for the emerging skills, I am interested also to hear how that looks from a university perspective as well. And to do that, maybe we can go to Jan next, because Jan, I would like to ask you from the academic and from the teaching perspective, how do you stay up to date on emerging skills? And really this question of emerging, actually that's what I'm interested in, as well as how often do you need to be looking for updates, looking to refresh things in your courses? So over to you, Jan.
Thank you for your question, Kristen. At IMT, we are a group of technical universities just spread in France. But if I can take just an example from IMT Atlantic, which is the one of the technical university that belongs to the Institut Mines Telecom, we have deployed a competency-based approach for the past 5 years, more or less. The idea is that the students are no longer evaluated on the knowledge only, that on their ability to transfer knowledge and the degree of abstraction that allows them to move from the knowledge to the competency, to the really core skills that they will require when they are going to the employment. So on how often, usually we re-examine annually the validity of the skills and competencies in close association with the French and international socio-economic partners. Indeed, as a technical university that belongs to the French Ministry of Industry and Finance, the close relationship with the industrials is in our DNA. And it is essential to consider the needs of tomorrow's employer for today's students. So for instance, we develop for the last 2-3 years, really new core topics and new skills. For example, Industry 4.0 or environment, energy, binary transition, or sustainable development, both of which are at the heart of the IMT expertise. And moreover, last but not least, the soft skills. Soft skills, obviously, that is one of the pillars of the engineer of the future. In particular, the notion of responsible engineering is very important in our, let's say, DNA. And it takes part of our raison d'être that has been redefined recently at the scale of the Institut Telecom. So we can cite some really precise examples. For example, we can cite the work with the Franco-German Academy for the Industry of the Future, where 4 MOOCs will be soon to be deployed on Coursera in the first part, where the first part of this MOOC will be deployed early 2022 in next spring. And so we are an approach like an ongoing development of content with continuous adaptation and improvement, both in blended or hybrid learning, within a framework, for example, of summer schools or winter schools. Actually, this week, this specific week, today, the IMT and Technical University of München developed a school using this Franco-German Academy, whose theme is When IoT Meets Cybersecurity. And so we can see that using this kind of framework, we can develop some new skills that is hot topics for the next employer with short-term intensive skills acquisition.
Thanks, Jan. And Jan, I'm guessing that you're going to say yes to this question, but we can elaborate. To what extent is the opportunity to do online learning and blended learning, is that helping the school introduce more emerging skills and emerging topics more quickly?
Yeah, that's true, because usually when you want to get new skills, you will have to register to a specific training, and then you will have to wait that the training will start, and then you are maybe sometimes going to move for a couple of weeks or 1 year when you want for continuing learning, for example. Actually, with this kind of blended or hybrid learning, you can just start your learning just immediately when the institution just make this content available online, and then you can do the practical works on the hands-on activities directly on site. And we are going to develop a kind of scalability of this hybrid learning. Let's say the idea is that everyone, for example, in France, can develop a specific activity online using our MOOCs, using our blended learning, and then they can go to a specific place. For example, when we talk about fabrication on Fab Labs, then we have a network of Fab Labs, and so you learn online with a couple of MOOCs that will be deployed in Coursera, for example, in the next months, on which you can directly learn let's say the knowledge, the basic knowledge. And when you want to go for your project and you want to go a step further, you are going to go to the Fab Lab that is next door, from which we have some partnerships, and they will be able to provide you the hands-on activity in order to make your learning in real and in concrete stuff. So we start to develop this kind of activity actually worldwide, and we have an experiment in Africa, in Central Africa. So we develop IMT at Dakar and so we have an hybrid program with online content that is produced in France with our team, and that is practical routes. It's provided by us, but deployed by our local partners. So in that sense, we can achieve scalability in the hybrid training.
Brilliant, brilliant example. Thank you very much for that. And this question of scalability and hands-on learning, that's another topic that I definitely want to come back to, because such a challenging in the engineering sphere, students, it's an applied topic. Students need to get their hands on. How can we do that in the online space? We will definitely come back to that. But it makes me want to go to Cécile for my next question, because you are at the heart of actually helping teachers integrate exactly what Jan's been talking about into their programs, update their programs, integrate new skills into their programs. So tell us a bit, Cécile, from your experience at EPFL, what are the challenges of introducing new skills into these engineering programs?
Thanks. That's a fascinating question. And so from our experience these last years, the challenges that I see relate very much to how we introduce those skills so that they are taught in the most effective way. And so I'm gonna illustrate this issue with two examples on which we have worked quite a bit. A first example is project management, so which includes skills such as planning, risk management, working in teams and stuff like that. And so to understand how to teach project management effectively, we have looked at existing research in education, and we have also collected data on campus to have a view of what was happening in our own context. For instance, from highly visible projects such as the Solar Decathlon, or this highly visible project competition. And what we have learned from these two types of research is that when we teach for project management in a separate course, well, actually students have a huge difficulty to transfer the skills into the practice of managing projects. So that's one thing. The other opposite is if we just put students to work on projects in the hope that they're going to learn project management simply from the practice, well, our data shows that it's not happening. And for this to happen, that students learn from that practice so that they learn from doing, we need to organize the projects in very specific ways with a special focus on the process and an intention that students will learn from the process with a reduced focus on the product or on what the students are producing. And in that type of teaching, which is very, very individual, very customized to the context, and in which teachers have to accompany student teams, there's an important role of teaching assistants. So, for instance, doctoral students or even master students who supervise students from a lower level. And so to tackle that challenge in particular, what we have done is a huge effort to train these assistants. So we have designed workshops, we have designed a MOOC, and we have designed also a book, which has been published very recently. I could share the link with you if you're interested. So that's a first example on project management, a first type of challenge. A second example I wanted to share with you is on computational thinking. And for us, so computational thinking is this ability to think and to solve problems using computation and digital tools. And since the beginning of the talk, we discussed a lot digital skills in that context. And in this case too, teaching computational thinking cannot be done separately from the disciplinary content. It's a skill that has to be taught in the context of a discipline for students to be able to use this skill. One of the reasons, in addition to it being a very practical skill, is also that it varies in the discipline. So the digital way of thinking about problems will be different if you think about it. In material science, versus in mechanical engineering. The type of tools that are used and the type of abstractions which are used are a bit different. So we needed to embed this skill in courses, which requires teachers to be on board. And that was the second part of your question. So the teacher has to be okay to remove something from a course. And also, I mean, even more importantly, the teacher needs to have those skills. So what we have done to tackle this issue is that 2 years ago, we have launched a project in which we have used a tool as a medium to introduce computational thinking into the courses. And that tool, probably you know about it, is called Jupyter Notebooks. We have chosen that tool because it implements the idea of computational thinking in practice, because in these notebooks, you have the thinking, which is textual description, potentially multimedia, and you have the computation part, which is code execution, and data processing. Many teachers use this tool in the research. And so actually, teachers got interested in using this tool that comes from the research into their teaching. And in the range of 2 years, I mean, we had a huge success. Many teachers started to use it. We're approaching 5,000 students on our Jupyter Lab platform. And we recently released a website sharing what we have learned from using Jupyter Notebooks for teaching, with advice on how to implement this computational thinking in practice in 5 different ways in the courses. To give you an idea, the 5 different ways are virtual demonstrations, virtual labs, exercise worksheets, interactive textbook, and graded assignments. So these were my 2 examples. Very recently, we have launched another project about a topic that Jan was mentioning, which is responsible engineering, especially in the domain of data science and in the domain of the design of information systems. So we want to introduce those skills transversally into the curriculum. We're not yet sure about the way to go. We're currently in that research phase where we look at the literature and we also pilot a few ideas and collect data on campus. That's the way we try to address these challenges. Sorry, that was a bit long.
No, not at all. That was a great thing to hear it about. And I think that this is a topic, this idea of the responsible engineering and socially conscious graduates is something that we're going to come back to. In fact, maybe we'll start talking less about digital skills on their own and more about digital skills and their role in society and for sustainability. That's a topic that I would very much like to cover in a future debate. But thank you very much for the input, and also the examples that you've shown by what you've achieved by accompanying professors through this process and providing tools. You mentioned a website. If you'd be happy to share that in the chat, that would be fantastic. I am sure that we will have others in the course, Cecile, who'd be really happy to look at that. So thank you very much for those examples. Okay. And once again, the idea of online labs. So we will definitely come back to that. But before we do, let's hear from Stefano. And Stefano, thank you so much for joining us. I mean, I'm really grateful to have your experience and would like to explore that from a couple of perspectives. Maybe first of all, to come back to that original question about, what are the emerging skills and how we identify them? What do you see from the interactions that you have with industry and that you hear from your colleagues about the skills that they need? What do you see as the emerging skills that engineering students are going to need? Over to you, Stefano.
Yeah. Apologies, there was an interaction in my connection. Can you please? Sure,
of course I can.
Just in the middle of the question,
No, yeah, that's perfect timing. No, but we can hear you loud and clear now. And my question was just coming back to that initial question: how do we identify emerging skills? What are you hearing from industry and from your colleagues working with industry about the skills that engineering students are going to need?
Yeah, so thank you very much for your question. That's really an interesting topic. So yeah, there are a number of different skills that we see are as particularly important. As for the industry perspective, we are aware of a recent survey from the American Society of Engineering and Education, and from this survey, what we can see is that key areas where that has emerged as gaps are artificial intelligence, simulation, digital twins, and system engineering. So those are really key technologies where there is, let's say, room for, let's say, for improvement in terms of the skills that the students are needed in order to fill those gaps. And what I can say is that there's definitely a big transformation happening right now, which involves the convergence of multiple technical areas towards system requiring multidisciplinary education as a strong asset for the engineering to be able to address the design challenges. So those key areas are really the focus for what we have been doing in collaboration with the universities. So one of the things that we've been doing has been to develop online courses to help professors, instructors, and students in order to tackle those technical challenges when it comes to learn any new development environment and programming language. So what we've been doing has been to develop courses focusing on both the foundation tools in order for the instructors and students to address those technical areas, as well as to develop courses in some specific technical areas like signal processing or AI, like machine and deep learning, control systems, or modeling physical systems. We've been also collaborating with closely with the universities to develop curriculum material to address those challenges. One of the things we've been doing pretty extensively, especially along the last 18 months because of the pandemic, has been to focus also on virtual lab content, as well as on the modular content as material that could be reused also by other universities in order to take advantage of the material. We've been also collaborating with universities in the development of MOOCs. We do have a dedicated team to support the development of MOOC courses. And yeah, we've also been collaborating with Coursera on that. So we've been developing content to provide students with the right skills that are needed by the industry by, let's say, focusing on our foundation tools like MATLAB and Simulink.
Okay, and Stefano, when you're looking then at what kinds of what are the specific modules or chunks that need to be integrated? If you think about, you mentioned systems engineering, for example, or predictive maintenance. What kinds of what might be there already? What might be missing that a university will need to think about integrating?
Right. So, yeah, I was happy to hear from Cecile. She was mentioning computational thinking. This is also what we can, let's say, see as, let's say, generally speaking, as something that where we still to fill a gap. Another one is model-based system engineering. So to me, those are the two fundamental skills that are needed by the students to be acquired in order to be able to address, let's say, key areas like the one you were mentioning before, predictive maintenance. Predictive maintenance is really about forecasting when problems will arise. And that's becoming more and more important for the industry as a way to reduce maintenance costs and also the risks of failure with the related dangers. So it's really a discipline which is growing really fast at the industry side. And it also requires a nice combination of technical skills the students should learn, like data science, particularly as regards that data acquisition, pre-processing, visualization, as well as machine learning techniques and handling big data, like Carlos was mentioning before. And the other one is modeling and simulation. So building realistic models for the system under study by creating a digital twin to be able to simulate its behavior and collect failure data. A digital twin is basically a software model of a real system, which allows you to, for example, to collect failure data by creating failure conditions in a way that you don't need to account for real system to break up, in a way that you can also save the associated costs with that.
That's brilliant, Stefano. Thank you, because you've linked perfectly into one of the topics that I know is a challenge, but also something vital for a lot of engineering schools, is this idea of having digital laboratories, in fact, and using the digital twin concept can exist in industry, in labs and in research as well. But basically giving students the opportunity to try something and test something out. So I'm going to maybe this is a question that we can all discuss, but I'm going to come to Carlos first and just say, what have you done? I suppose people think Coursera, okay, I can study a course or a program. Is there any lab work opportunity in that online learning environment? How do you do that?
Yeah, great, thank you. Yeah, I mean, Coursera has tackled this head first in terms of helping global. Today we have 2,700 enterprises using our content, 3,200 campuses, other universities using the content to really tackle this sort of phenomenon. When it comes to practical hands-on learning, the one thing that has had the most success in terms of our campuses that are using Coursera is what we call the Coursera Labs. And Coursera Labs is essentially a suite of two tools that we use integrated within our platform and within our courses that allows students to really have a hands-on experience. The first one being, the labs assignment, what we call labs assignment, which is, your Jupyter notebook integrated into a course, RStudio, VS Code, and other cloud software applications. And the second one, which is the more recent one, is the guided projects, which allows it's short projects, less than 2 hours, very specific towards a very specific skill or very specific tool, usually software. And it allows on browser the student to follow a guided professor or somebody, following a guided lesson. And on the other side of the screen, they are, on browser again, without having to download anything. They're running the software that allows them to practice what they're learning. So this has had a huge impact, obviously. But beyond this, I think also what's interesting and what we've seen is the idea that universities or campuses using our solutions are also able to use essentially the courses, the Coursera courses, to gain time, to gain efficiency, money, essentially, or save money, and quality in teaching when it comes to their on-campus offering. When it comes to time, all of a sudden you don't need to rely on finding the right professors to teach the right kind of skills. You have pre-made sort of solutions that you can just rely with and just pick up. When it comes to costs, efficiencies, well, you're reducing your delivery costs by going to Coursera, and you're increasing sort of the capacity, because all of a sudden you're teaching online, and so I think this is also allowing them to increase the quality, and essentially when they come to campus they can be more hands-on, right? What we call learning, etc. concepts are being facilitated by all of this. Nothing necessarily new, but we're seeing a huge uptake in this as well from our partners. Yeah, I think I'll stop there for now. I mean, plenty I can talk to, but I'll stop for now.
About this, yeah, about the online labs and the hands-on learning aspect. There's maybe something that I would like to ask Cécile about related to that as well, which is, beyond simply learning experimentation and the lab testing that the students are doing. What do you learn from that kind of hands-on experience? And can that be something that you can experience online? What's your view on that?
Yeah, that's a very good question that, of course, we had to think about during the pandemic, because it's true that manipulation skills, so operating systems, suddenly was not possible anymore. And we had to center our practical work on other types of skills. So we really thought about, okay, what do we expect students to learn from this learning from doing, from these practical sessions? And in particular, there are lots of skills on the inquiry process. So for instance, formulating a scientific question, designing an experiment, that's for the skills at the beginning. And then, okay, once you have an experiment and you have data, then here comes the data science part of it. So how do you analyze data? How do you work with evidence? How do you draw conclusions? And how do you think critically about those conclusions? Because it's not enough to have a number or to have, a result at the end that says, well, the difference between this and that is significant. And how do you assess critically this result? And we think these skills are super essential for all students to get if they want to be able to interpret what's happening right now with the information shared on the scientific results. How do you interpret them, and how do people maybe focus on parts of them, and how do you see what's missing maybe in their interpretation? How do you come back to how the experiment was designed? So these are the skills that we focus very much on. And how we did implement that in practice. So Carlos was mentioning the labs assignments. Of course, we've done a lot of that with Jupyter Notebooks, of course, which are very practical for online. Some of our teams also developed remote labs that you can control directly from a MOOC. So that allows students who attend a MOOC to manipulate an equipment at the distance and have a feedback, for instance, in the form of a camera visual or from reading the instruments. And then they collect data directly from those instruments remotely. And more recently, no, but a number of other researchers have focused on virtual labs, so virtual versions of real experiments, which have benefits and drawbacks, of course, because they're virtual, so they don't have that messiness of the reality. But because they're virtual, you can add or remove information to make them more pedagogical, more efficient in terms of learning. Yep, that's the different types of approaches we have used.
Brilliant input. Thank you, Cécile. And also the idea, whatever the experimentation itself is part of the learning process. That's fantastic. I'm going to come to you in a second, Jan. I think you've got something to add there. I just wanted to highlight as well, we'd love to hear from everybody in the audience. We've got a great collection of representatives here from universities and industry. So please do post your questions. If there's something that you'd like to ask, or if there's something that you'd like to share, there's a load of great resources in that chat. You're welcome to save it, and we'll make sure that it's saved, it's shared as well after the event. But please don't hesitate to post about something that you've been doing, or write your question there or in the Q&A, of course, so that we can put those questions to our panel. So let me come to you, Jan, just on this topic of virtual labs. What's your experience been of in implementing virtual experimentation, virtual lab work?
Yeah, thank you, Kristen. I think we can illustrate our expertise with several different examples, because we try to adapt our experience according to the skills or to the topics that we want to aim. So the idea is, for example, we developed directly inside IMT a task grader. So task grader is an open source software that we use in different MOOCs courses in order to automatically an automated grader to assess the submission of codes that the learners send directly in order to validate their lab, their virtual lab, let's say, or Codecast, which has been developed for our language C MOOCs also. This is really interesting because in that case you are emulated some environments on which the learners can just take the experience, the real life experience, but in totally virtually. We developed also with partners a specific emulator, for example, for small PC, small computer that we developed, like some very cheap computer. I won't say the trademark, just in order to not do publicity, but you imagine what I thought about. And so we developed especially a specific emulator on which virtually you can just bridge some link, like electrical link, directly online on the website that is integrated in the MOOC environment. And so you can just do practical stuff directly on your computer without buying some specific equipment. And last but not least, we have, for example, especially also another type of experiment with the public of job seeker, for example, and the cross-fertilization that we have between engineers, makers, designer, with a specific MOOC that is modeling in 3D. We developed it with a specific school of arts in Rennes. And so we integrate a specific plugin into a real open source software. So this specific open source, inside the open source software, we develop a specific plugin. So the idea is that the learners can do directly the hands-on activity on the software, like in a real life. And so in real time, they just have a small column on which they can see their progress with green or yellow or red mark, let's say, just to see if they're doing something wrong or is they are in a good advance for the developing on the practical hands-on activity. And so the learners works really in the future environment without doing an emulation or something like that. No, it's a real software that they will use after their certification. And so they validate the manipulation in real time and help the colleague to grade the submission automatically.
Brilliant example, thank you. And again, Cecile and Jan, what you've both been talking about, that approach hasn't just happened overnight. Even when universities have had to do things very quickly in this COVID environment, I'm just wondering, once again, just to share the learning with everybody who's here, what kind of challenges did you have to overcome? Anything specific that jumps to mind? And are you satisfied with the results? Is there something that you're still working on that you want to improve further? And
I'm happy to respond to that. Yeah, it's true. We had to do a huge move suddenly, but a lot of things were ready. I mean, our colleagues who were developing the remote labs, our colleagues who were developing the virtual labs, the Jupyter Notebook platform was already there. So it was smooth in that respect. Now we are building on that experience and trying to learn from what we have done and what we could continue with. So to give you two examples, we have launched 2 commissions. to think about transversal skills. So these professional skills that we want our learners to have ready when they graduate, so that they're ready for the work environment. So we have a commission working on that and looking at how to support this learning with, in particular, projects, project-based learning. And another commission, so we have 4 in total, but I'm going to just describe 2. The other commission is working on hybrid teaching. So how to transform that experience of having the chance to use these online tools, all these digital tools that have a lot of advantages. How can we transform that into a positive learning experience for all students? And that includes, of course, flipped classrooms, for instance. I'm not sure, maybe we're going to talk about this a bit later. But flipped classrooms are one model, and we're looking at other potential models. This is very early, still in the work of the commission, but yeah, we're looking at how to move from there.
Okay. Looking forward to hearing the audience view and experience on that as well. Jan, tell us, what have you learned? What challenges have you overcome in implementing your approach?
Yeah, from our point of view, we are quite used in developing some online activities. So as Cécile said, the flipping to go only in full online was not a very, very big deal for our professors and teachers. But, you know, we are the first university in France that developed a scientific MOOC in 2013. And it was a quite long story for online courses. But what we discover is that the learners, the student themselves, was not ready for a full online experience. They don't want a full online experience. They need relationship. They need social interaction, and so they ask for the whole during the whole long months that the COVID pandemic makes their life only in a small room in a dorm, for example, for students. They ask really for on-site activities. They want to come back directly in the university. So they are not against online courses, but they want to hybrid activities. They want to do both. They want to have this liberty to learn when they want, to learn at the rhythm that they want, but sometimes they need to have synchronized activity with let's say, real life interaction and sociability.
Yeah. Getting that balance right is a challenge for institutions, because in fact, students as individuals, as we all are, all want something different as well. So then you hear the whole cohort of students and think, okay, how can we address the needs of each of them? But isn't that the brilliant thing about online learning, is that it doesn't need to be distance learning. It can be, hybrid and blended, so that we can bring something that suits each individual and hopefully improve student engagement in the process. Just, I think, as our last question, because we're going to come right to the end, and Stefano, I'm really keen to hear your experience on that. What challenges have you faced over the last months, implementing what you're doing with institutions? Have you got any insight or tips that you could share?
Yeah, well, that's a very interesting question. Well, of course, besides the technical challenges that the universities had to address 18 months ago, that was really a huge demand in terms of moving to online technologies, but then that was also an opportunity for the universities to be more familiar with all the, let's say, online and virtual capabilities. The other challenge was, of course, keeping the students engaged. That was really a huge challenge. And I've seen many professors and instructors moving towards the adoption again of online and virtual techniques and methodologies to stay engaged with the students. It was really a nice opportunity for them to let's say, to move to more virtual ways to teach. Virtual labs, virtual content was something that I've seen growing a lot. The adoption of cloud technologies was another big area. We've been working a lot with universities to help them adopting the use of our tools online in the cloud. That was something that was really a big step for them. And yeah, also, I mean, in terms of working with the simulated systems was also another key driver, which was, you know, good for methods. I mean, we are promoting model-based system engineering as let's say as a workflow that should be adopted both within universities and the industry. And I've seen universities embracing this idea of going towards software simulations, software models, digital twins. So in the end, I mean, even though, of course, we all know the pandemic was really a struggle and a challenge, nevertheless, I can see there was also some benefits coming out from this.
Stefano, you've finished on a perfect point for our discussion that, yeah, we're all learning and we're all trying to make the most of what's been an extremely challenging situation, but to jump much further ahead as a result of it. And with the insight and the expertise that you've all shared, I'm sure we'll be able to do more of that. We seem to have lost Carlos, so I hope that Carlos will rejoin again. So you're brilliant. You're there. Great. Good to have you with us. Just very, very quickly to wrap up then, we'll have a couple of slides on just to explain what's going to happen next, and we'll come back to all of you, just if you've got like literally a 20-second comment, if there's anything that you would like to share to wrap up. But Dominic, if you could just if you just put the slides up. My screen's a bit slow, perhaps, so if I don't see them. There you go. All right, so to our audience, thank you all for staying with us during the course of this webinar. Thank you for the questions and for the exchange as well that has been in the chat. That is great. We will send you a survey to ask you for your feedback, and in particular any future topics that you would find useful to cover. So please do comment on that. Our final webinar of the year will be hosted in collaboration with Minaris, Middle East and North African Association for Engineering Education. So please do join us for that on Tuesday the 7th, and there's a link to join there in the chat that you can also click on. And you obviously have the link there to Coursera for Campus. Find out more. There are lots of people in the chat who you can exchange with about that. If you would just jump onto the next slide, please, Dominic. Here we go. We're going to paste in a second. We'll paste the link to our Wonder Room. For those of you who haven't used Wonder before, it's just a fun and interactive. If you know Harry Potter, it's like that Marauder's map of Harry Potter, people floating around. You don't quite know who is everybody and where they are, and then you slide over to somebody and your cameras come on and you can talk directly. It's the closest thing that we found to an actual coffee break or cocktail after a webinar. So if any of you can stay, we'd be delighted to stay and chat with you too. It's absolutely optional, and we'll just stay there for about a maximum of about 20 minutes. So please do join that link once it's posted in the chat. But just before we do that, and in our final minute, in fact, we're just over time, so thank you for sticking with us. Can I just go very quickly to our panel? First of all, thank you for everything that you've shared, for being so generous and sharing your experience, what you're trying, where the challenges are, and what you're learning as we go along. It's really valuable to have that. Has anybody got something that you would like to share just as a final comment? Just give me a wave, and let's have a wrap-up comment from anybody who would like to share something further before we close. Cecile, go for it.
Just to say that I was super interested to learn about what all the others were doing. It looks like we're doing a lot in terms of trying to develop the new skills for engineers. So that was very interesting for me. So thank you very much.
Brilliant. Thank you for sharing as well. Carlos, Stefano, I'm sure if people want to follow up on any of the links, anything that they've heard about, they'll be able to connect with you. LinkedIn, of course, is obviously brilliant for that, but you're also welcome to come back to us as the organizers if you would like to do so. Yeah, just once again, very much thanks, Joel. Anybody else wanted to say something before we move over to our networking session? Thank you, audience, by the way, for your comments. Tagwas, and we're good to hear from you. Jan, go ahead, please.
Yeah, I can just say a very warm thank you for organizing this very interesting webinar. I'm also very looking forward for next step now, and I think we are quite in a corner of the street where we know now how to use MOOCs and how MOOCs start to be like a standard, but it's only a pieces in our new way of learning, and so how to reach scalability in a blending or hybrid learning using MOOCs as a building block will be a very new challenge that I'm very interested to share with anyone who wants to talk about this next step in the future of learning.
Brilliant. We're all learning from each other. So it's one of the things that we appreciate the most in this period. Stefano, let's hear from you, and then I'll come to Carlos for a final word, and we'll jump into our networking. Stefano, over to you.
Yeah, so again, also from my side, thank you very much for inviting us. That's been really a very interesting discussion. Also wanted to share with the audience, just in case you need any help, please feel free to reach out to us. We'll be more than happy to help with your challenges in the let's say in the adoption of the digital technologies, especially as regards our tools, and also in terms of your potential interest in developing teaching material or MOOCs, also in collaboration with Coursera. Again, please feel free to reach out to us.
Brilliant.
And thank everyone.
Thank you, Stefano. Good to have you with us again. And Carlos, over to you.
Yes, thank you. I mean, to be honest, first and foremost, thank you so much to my partners, EPFL and IMT, for joining. I think we're entering an era that's going to be very interesting to see, what comes up, what disruptive innovation comes up in terms of teaching online and practical teaching on digital medias. And so I'm very much looking forward to this new chapter in teaching and to everything that it holds. And thank you very much for hosting us, Kirsten and Stefano, for your insightful input. I'm very happy to be working with you all.
Brilliant. Thank you, Carlos. So Dominic, if you can go ahead and put the Wonder link there. Brilliant. Thank you. You will have to leave Zoom to join Wonder. Do give it a try if you haven't used it yet. It's a lot of fun. Carlos, thank you. We're really privileged and delighted to be working with Coursera on this series, and really grateful that you've brought together these experts with us who can share what they're working on. Audience, thank you all especially. I know we spend a lot of time in front of our screens these days, and it was really delightful to have you with us for this webinar, and I hope that you will join us for the final one in the series. And with that, I'm going to say thank you and over and out to everybody. And I hope that you will click on the Wonder link, and I'll see you there for a very short imaginary coffee break, all happening online. It was great to be with you all. Thank you very much. And I look forward to the next one.